The Arleigh Burke class of guided missile destroyers is the United States Navy's first class of destroyer built around the Aegis Combat System and the Spy-1D multifunction phased array radar. The class is named for Admiral Arleigh Burke, the most famous American destroyer officer of World War II, and later Chief of Naval Operations. The class leader, USS Arleigh Burke, was commissioned during Admiral Burke's lifetime. They were designed as multi-role destroyers to fit the ASUW role with their powerful Aegis radar and anti-aircraft missiles. ASUW role, with their towed sonar array, anti-submarine rockets, and ASW helicopter. ASUW role with their Harpoon missile launcher. And strategic land strike role with their Tomahawk missiles. Some versions of the class no longer have the towed sonar, or Harpoon missile launcher. Their hull and superstructure were designed to have a reduced radar cross-section. The first ship of the class was commissioned on July 4, 1991. With the decommissioning of the last Spruance-class destroyer, Cushing, on September 21, 2005, the Arleigh Burke Euro-class ships became the U.S. Navy's only active destroyers. The class has the longest production run for any postwar U.S. Navy surface combatant. The Arleigh Burke class is planned to be the third most numerous class of destroyer to serve in the U.S. Navy, after the Fletcher and Gearing classes. Besides the 62 vessels of this class in service by 2013, up to a further 42 have been envisaged. With an overall length of 505 feet to 509 feet, displacement ranging from 8,315 to 9,200 tons, and weaponry including over 90 missiles, the Arleigh Burke Euro-class ships are larger and more heavily armed than most previous ships classified as guided missile cruisers. Characteristics: the Arleigh Burke class is among the largest destroyers built in the United States. Only the Spruance and Kidder classes were longer. The Arleigh Burke class are multi-mission ships with a combination of an advanced anti-submarine warfare system, land attack cruise missiles, ship-to-ship missiles, and advanced anti-aircraft missiles. The larger Ticonderoga-class ships were constructed on Spruance-class hull forms, but are designated as cruisers due to their radically different mission and weapons systems. The Arleigh Burke class on the other hand were designed with a new, large, waterplane area hull form characterized by a wide flaring bow which significantly improves sea-keeping ability. The hull form is designed to permit high speed in high sea states. The Arleigh Burke's designers incorporated lessons learned from the Ticonderoga-class guided missile cruisers. With the Arleigh Burke class, the U.S. Navy also returned to all-steel construction. An earlier generation had combined a steel hull with an innovative superstructure made of lighter aluminum to reduce top weight, but the lighter metal proved vulnerable to cracking. Aluminum is also less fire-resistant than steel. A 1975 fire aboard USS gutted her aluminum superstructure. Battle damage to Royal Navy ships exacerbated by their aluminum superstructures during the 1982 Falklands War supported the decision to use steel. Another lesson from the Falklands War led the Navy to protect the ship's vital spaces with double-spaced steel armor, and Kevlar spool liners. The Ticonderoga-class cruisers were deemed too expensive to continue building and too difficult to further upgrade. The angled rather than traditional vertical surfaces and the tripod mainmast of the Arleigh Burke design are stealth techniques, which make the ship more difficult to detect, in particular by anti-ship missiles. A collective protection system makes the Arleigh Burke class the first U.S. warships designed with an air filtration system against nuclear, biological and chemical warfare. Other NBC defenses include a countermeasure washdown system. Their Aegis radar differs from a traditional rotating radar that mechanically rotates 360 degrees for each sweep scan of the airspace, which allows continual tracking of targets. The system's computer control also allows centralization of the previously separate tracking and targeting functions. The system is also resistant to electronic countermeasures. Their standalone Harpoon anti-ship missile launchers give them an anti-ship capability with a range in excess of 64 nm. The 5" /54 caliber Mark 45 gun, in conjunction with the Mark 34 gun weapon system, is an anti-ship weapon which can also be used for close-in air contacts or to support forces ashore with naval gunfire support, with a range of up to 20 miles and capable of firing 20 rounds per minute. The class's IM-7C Sparrow missiles provide point defense against missiles and aircraft, while the Standard missile provides area anti-aircraft defense. Additionally, the ship has an electronics warfare suite that provides passive detection and decoy countermeasures. The class's light airborne multipurpose system, or LAMPS helicopter system, improves the ship's capabilities against submarines and surface ships, a helicopter able to serve as a platform to monitor submarines and surface ships, and launch torpedoes and missiles against them, as well as being able to support ground assaults with machine guns and Hellfire anti-armor guided missiles. The helicopters also serve in a utility role, able to perform ship replenishment, search and rescue, medical evacuation, communications relay, and naval gunfire spotting and controlling. Arleigh Burke Euro-class destroyers have many combat systems. Burkes have the Navy's latest anti-submarine combat system with active sonar, a towed sonar array, and anti-submarine rockets. They support strategic land strikes with their VLS-launched Tomahawks. They are able to detect anti-ship mines at a range of 1,400 yards. So vital has the Aegis ballistic missile defense system role of the class become that all ships of the class are being updated with BMD capability. Burke production is being restarted in place of additional Zumwalt-class destroyers. Development. In 1980, the U.S. Navy initiated design studies with 7 contractors. By 1983 the number of competitors had been reduced to 3, Bath Iron Works, Todd Shipyards and Ingalls Shipbuilding. On April 3, 1985, Bath Iron Works received a $321.9 million contract to build the first of class, USS Arleigh Burke. Gibbs & Cox was awarded the contract to be the lead ship design agent. The total cost of the first ship was put at $1.1 billion, the other $778 million being for the ship's weapons systems. She was laid down by the Bath Iron Works at Bath, Maine, on December 6, 1988, and launched on September 16, 1989 by Mrs. Arleigh Burke. The Admiral himself was present at her commissioning ceremony on July 4, 1991, held on the waterfront in downtown Norfolk, Virginia. The Flight IIA Arleigh Burke ships have several new features, beginning with the USS Oscar Ostina, DDG-79. Among the changes are the addition of 2 hangars for ASUW helicopters, and a new, longer Mark 45 Mod 4 5-inch/62 caliber naval gun in later ships. Later Flight IIA ships starting with USS Mestina, DDG-89, have a modified funnel design that buries the funnels within the superstructure as a signature reduction measure. Tactor's towed array sonar was omitted from Flight IIA ships and they also lack Harpoon missile launchers. Ships from DDG-68 to DDG-84 have ANSLQ-32 antennas that resemble V-3 configurations similar to those deployed on Ticonderoga-class cruisers, while the remainder have V-2 variants externally resembling those deployed on some Oliver Hazard Perry-class frigates. V-3 has an active electronic countermeasures component while V-2 is passive only. A number of Flight IIA ships were constructed without a Phalanx CIWS because of the planned evolved Sea Sparrow missile, but later the Navy decided to retrofit all IIA ships to carry at least one Phalanx CIWS by 2013. USS Pinckney, USS Mompson, USS Chung-hoon, USS Nitz, USS James E. Williams and USS Bainbridge have superstructure differences to accommodate the remote mine hunting system. Mk-32 torpedo tubes were moved to the missile deck from amidships as well. Modernization. The U.S. Navy has begun a modernization program for the Arleigh Burke-class aimed at improving the gun systems on the ships in an effort to address congressional concerns over the retirement of the Iowa-class battleships. This modernization was to include an extension of the range of the 5-inch guns on the Flight IIA Arleigh Burke Euro-class destroyers with extended-range guided munitions that would have given the guns a range of 40 nautical miles. However, the ERGM was cancelled in 2008. The modernization program is designed to provide a comprehensive mid-life upgrade to ensure that the class remains effective. reduced manning, increased mission effectiveness, and a reduced total cost including construction, maintenance, and operation are the goals of the Modernization Program. Modernization technologies will be integrated during new construction of DDG 111 and 112, then retrofitted into DDG Flight IIA ships during in-service overhaul periods. The first phase will update the hull, mechanical, and electrical systems while the second phase will introduce an open architecture computing environment. The result will be improved capability in both ballistic missile defense and littoral combat. By 2018 all Burkes home-ported in the Western Pacific will have upgraded anti-submarine systems, including the new ANSQR-20 multifunction towed array. The Navy is also upgrading the ship's ability to process data. Beginning with USS Spruance, the Navy is installing an Internet Protocol-based data backbone, which enhances the ship's ability to handle video. Spruance is the first destroyer to be fitted with the Boeing Company's Gigabit Ethernet data multiplex system. In July 2010 BAE Systems announced that it had been awarded a contract to modernize 11 ships. In May 2014 Sam Lagrone reported that 21 of the 28 Flight IIA Burkes would not receive a mid-life upgrade that included electronics and Aegis Baseline 9 software for SM6 compatibility. Instead they would retain the basic $3.6 Bermudian $0.1 software in a $170 million upgrade concentrating on mechanical systems and on some ships, the anti-submarine suite. 7 Flight IIA ships, DDG 51-53, 57, 61, 65, 69, will get the full $270 million Baseline 9 upgrade. Deputy of Surface Warfare Dave McFarland said that this change was due to the budget cuts in the Budget Control Act of 2011. Production restarted and further development, the class was scheduled to be replaced by Zumwalt-class destroyers beginning in 2020, but an increasing threat from both long- and short-range missiles caused the Navy to restart production of the Arleigh Burke Euro class and consider placing littoral combat mission modules on the new ships. In April 2009 the Navy announced a plan that limited the Zumwalt class to 3 units while ordering another 3 Arleigh Burke Euro class ships from both Bath Iron Works and Ingalls Shipbuilding. In December 2009 Northrop Grumman received a $170.7 million letter contract for DDG 113 long lead time materials. Shipbuilding contracts for DDG 113 to DDG 115 were awarded in mid-2011 for $679.6 MAR Euro $783.6 million. These do not include government-furnished equipment such as weapons and sensors which will take the average cost of the FY 2011/12 ships to $1,842.7 million per vessel. DDG 113 to DDG 115 will be restart ships, similar to previous Flight IIA ships, but including modernization features such as open architecture computing environment. DDG 116 to DDG 121 will be technology insertion ships with elements of Flight 3, and Flight 3 proper will start with DDG 122. Flight 3 ships, construction starting in FY 2016 in place of the cancelled CG-X program, have various design improvements including radar antennas of mid-diameter increased to 14 feet from the previous 12 feet. These air and missile defense radars use digital beamforming, instead of the earlier passive electronically scan array radars. However, costs for the Flight 3 ships increased rapidly as expectations and requirements for the program have grown. In particular, this was due to the changing requirements needed to carry the proposed air and missile defense radar system required for the ship's ballistic missile defense role. The Government Accountability Office found that the design of the Flight IIIs was based on a significantly reduced threat environment from other Navy analyses, and that the new ships would be at best marginally effective. The U.S. Navy disagrees with the GAO findings, claiming the DDG-51 hull is absolutely capable of fitting a large enough radar to meet requirements. Installation of the AMDR would require double the power and double the cooling, but there is room to fit what is needed inside the hull. In spite of the production restart, the U.S. Navy is expected to fall short of its requirement for 94 missile defense-capable destroyer and cruiser platforms starting in FY 2025 and continuing past the end of the 30-year planning window. While this is a new requirement as of 2011, and the U.S. Navy has never had so many large missile-armed surface combatants, the relative success of the Aegis ballistic missile defense system has shifted this national security requirement onto the U.S. Navy. The shortfall will arise as older platforms that have been refitted to be missile defense capable are retired in bulk before new destroyers are planned to be built. The U.S. Navy was considering extending the acquisition of Arleigh Burke Euro-class destroyers into the 2040s, according to revised procurement tables sent to Congress, which have the U.S. Navy procuring Flight IV ships from 2032 through 2041. However, this was cancelled to cover the cost of the Ohio replacement submarine, with the Air Defense Commander role retained on one cruiser per carrier battle group. Future replacement. In April 2014, the U.S. Navy began the early stages of developing a new destroyer to replace the Arleigh Burke Euro-class called the Future Surface Combatant. The new class is expected to enter service in the early 2030s and initially serve alongside the 22 Flight III DDGs. No hull design or shape has been speculated yet, although the destroyer class will incorporate emerging technologies like lasers, onboard power generation systems, increased automation, and next-generation weapons, sensors, and electronics. They will leverage technologies in use on other platforms such as the Zumwalt-class destroyer, Littoral Combat Ship, and Gerald Ford Euro-class aircraft carriers. The Future Surface Combatant may place importance on the Zumwalt-class destroyer's electric drive system that propels the ship while generating 58 megawatts of onboard electrical power, levels required to operate future directed energy weapons. Laser weapons systems are likely to become more prominent to engage threats without using missiles that could potentially cost more than the target it is engaging. Less costly weapon systems may help keep the destroyer class from becoming too expensive. Initial requirements for the Future Surface Combatant will emphasize lethality and survivability, as well as being able to continue to protect aircraft carriers. The ships also have to be modular to allow for inexpensive upgrades of weaponry, electronics, computing, and sensors over time as threats evolve. Operational history. Arleigh Burke Euro-class destroyer Ussur was damaged on October 12, 2000 in Aden, Yemen while docked, by an attack in which an apparently shaped charge of 200 300 kg in a boat was placed against the hull and detonated by suicide bombers, killing 17 crew members. The ship was repaired, and returned to duty in 2001. In October 2011 it was announced that 4 Arleigh Burke Euro-class destroyers would be forward deployed in Europe to support the NATO missile defense system. The ships, to be based at Naval Station Rota, Spain, were named in February 2012, as Ross, Donald Cook, Porter and Carney. By reducing travel times to station, this forward deployment will allow for 6 other destroyers to be shifted from the Atlantic in support of the pivot to East Asia. Russia has threatened to quit the New START treaty over this deployment, calling it a threat to their nuclear deterrent. Contractors, builders, 34 units constructed by General Dynamics, Bath Iron Works Division and 28 by Northrop Grumman Ship Systems, Ingalls Shipbuilding, AN Spy-1 Radar and Combat System Integrator, Lockheed Martin, Shipson-class, USS Michael Murphy was originally intended to be the last of the Arleigh Burke-class. However, with reduction of the Zumwalt-class production, the U.S. Navy requested new DDG-51 class ships. Long lead materials contracts were awarded to Northrop Grumman in December 2009 for DDG-113 and in April 2010 for DDG-114. General Dynamics received a long lead materials contract for DDG-115 in February 2010. It is anticipated that in FY 2012 or FY 2013, the U.S. Navy will commence detailed work for a Flight III design and request 24 ships to be built from 2016 to 2031. In May 2013, a total of 77 Burke-class ships was planned. The Flight III variant is in the design phases of 2013. In June 2013, The U.S. Navy awarded $6.2 billion in destroyer contracts. Up to 42 Flight III ships are expected to be procured by the U.S. Navy, with the first ship entering service in 2023. Foreign interest. In May 2011, Saudi Arabia received a price estimate for the purchase of Arleigh Burke Euro-class destroyers. Gallery. The Last Ship television series features a fictionally named Burke-class destroyer and crew. See also: Conga-class destroyer, Japanese, Artigo-class destroyer, Japanese, Kolkata-class destroyer, India, Horizon-class frigate, Franco-Italian, Fridtjof Nansen-class frigate, Norwegian, Sejong the Great-class destroyer, Korean, an Lvaro de Baza N-class frigate, Spanish, Hobart-class destroyer, Australian, Type 45 destroyer, United Kingdom, FREMM multipurpose frigate, Franco-Italian, Type 052D destroyer, Chinese, De Zeven Provinciën-class frigate, Dutch, Iver Huitfeldt-class frigate, Danish, Sachsen-class frigate, German, notes. References: Baker, A.D. The Naval Institute Guide to Combat Fleets of the World 1998 to Euro 1999. Annapolis, Maryland, Naval Institute Press, 1998. ISBN 1-55750-111-4. Gardner, Robert and Chumbley, Stephen. Conway's All the World's Fighting Ships 1947 to Euro 1995. Annapolis, Maryland, Naval Institute Press, 1995. ISBN 1-55750-132-7. Further reading: Sanders, Michael S. The Yard, Building a Destroyer at the Bath Iron Works. New York, HarperCollins. ISBN A0-06-019246-1 at Bath Iron Works. External links: Arleigh Burke-class destroyers at Destroyer History Foundation, Arleigh Burke unit list on globalsecurity.org, Arleigh Burke-class page on naval-technology.com.